Okay, we're going to go through the chapter 6 notes. In the 1700s, Lavoisier compiled a list of all the known elements at the time, and he categorized them as simple substances, gases, metals, nonmetals, earths, all those sort of things. And then in the 1800s, there were large amounts of information, and scientists needed a way to organize knowledge about the elements. So John Newlands proposed an arrangement where the elements were ordered by increasing atomic mass. He noticed when the elements were arranged by mass that their properties started to repeat by every eighth element. Two other scientists, Meyer and Mendeleev, they both demonstrated a connection between atomic mass and elemental properties. And Moseley rearranged the table by increasing atomic number, and this resulted in a clear periodic pattern. So atomic mass wasn't the correct way to arrange the periodic table. It was by atomic number, which is how our current periodic table is arranged. When you arrange elements by their atomic number, a periodic pattern appears, and chemical and physical properties of those elements are shown. And we'll start to learn about the groups, and you'll see how those fit together as well. This is called the periodic law. These are some of the contributions by the scientists and how the periodic table was developed over time and those time frames. So you can look at that. And on our modern periodic table, we have the atomic number, we have the mass number, we have the symbol for the element, and we have the name of the element. And each element has its own box. The columns, or the vertical columns, are called the groups, and the horizontal rows are called the periods. Groups 3 through 12 are known as the transition metals, and there are specific names for groups 1, 2, and 13 through 18. We actually labeled those already on the periodic table that we colored, so we'll be referring back to that too. So we can break metals into, we can split up the elements into different categories, metals, nonmetals, metalloids. And metals are the characteristics of metals. They're shiny and they are normally solid at room temperature. The exception to that is mercury. They're also good conductors of heat and electricity. That's why we use them for wiring and things like that. Group 1 elements are known as the alkali metals. They're very reactive and you don't actually find them free in nature, meaning you can't go to a mountain and dig up sodium or lithium or potassium or any of those alkali metals. You would find them combined with other elements, and they have to be chemically separated from those elements in order to achieve the pure substance. The alkaline earth metals, those are group 2. They're also highly reactive. You're not going to find them uncombined in nature either. Then we have the transition metals. Those are the elements 3 through 12, those groups, and the intertransition metals as well. Those are called the lanthanide and the actinide series. That's the 4F and the 5F block. They kind of squeeze in there between the 6S and the 7S, and they are also considered transition metals. Nonmetals, they are poor conductors of heat and electricity. They're brittle. They're basically the opposite of whatever a metal is. What the properties that metals have, nonmetals don't. And there are a wide variety of properties because a lot of the nonmetals are gases. Some are solids. And if they're solids, they're brittle solids. Group 17 is one of the groups of nonmetals that has a lot in common. And they are highly reactive. They're the most reactive of the nonmetals, and they're called the halogens. Group 18, they're very unreactive because they have a full set of valence electrons or outermost electrons. They're very stable and they're called the noble gases. Then we have those elements that border the zigzag line that separates the metals from the nonmetals. Those are called the metalloids, and they have some of the properties of metals and some properties of nonmetals. So here's the periodic table and how it's divided. I had you guys do a color code of this already, so this is just kind of a look at that.